Number one asks us to prove if the two triangles are similar. So all we're given is that these intersect at point E, and we're given these measurements. So first of all, I think this is going to be side angle side because I have two sides but not the third side, and then we know that these are vertical angles. So checking side angle side, first thing we need to show is the included angle. So angle AED is congruent to BEC, and the reason for that is they're vertical. Okay, now we need to show that the proportions or the ratios of the sides are equal. So looking at these two, 2 is the smaller side, 3 is the medium, and then on the other side, 1 is the smaller side, 1.5 is the medium. So I'm going to check that 2 over 1 equals 3 over 1.5, and these both simplify to 2. So this shows me that the corresponding sides are proportional. So then we're going to say yes, similar by side angle side. All right, for part B, the picture looks similar, but the information given is different. So we're not given any side lengths. So that tells me that this is probably angle, but in order for it to be angle, we need two pairs of angles to be congruent. Well, the first pair that's given to us is that angle G is congruent to angle V, and that's given. And just like the previous one, we have this angle, which I'm going to call angle GHF, is congruent to angle VHW, and the reason is they're vertical angles. So that shows me that two angles are congruent, so we would say yes, similar by angle. All right, so number 2, it's asking the same thing. We're determining if they're similar. We're going to show why or why not. So looking at 2A, I see that I have two sides, but I don't have the third side, which tells me it's probably side angle side. The angle that I can mark as being congruent is this one. Remember that in side angle side, the angle that's congruent has to be the included angle. Well, in this case, since the sides on triangle JKL are labeled over here and the included angle would be 42, the congruent angle is not the one that we need. So we would say that these are not similar. And I'm going to say because the congruent angle, because there is a pair of congruent angles, it's the vertical angle, because the congruent angle is not the included angle. All right, so B, this is a challenge problem. You will not need to know how to do this for the test, but it is good to know. It's a little bit more of a difficult problem. So what I suggest that you do is draw these kind of separately and match them up. So this is BAD, and then we have the smaller triangle, which is ACD. So what I know about BAD is BA is square root of 89, BD is 8, and DC is 3. Well, we know that these are right angles, which means we can use Pythagorean theorem. So what I'm actually going to do is I'm going to use Pythagorean theorem to solve for this side, which is also going to be this side. Okay, so using Pythagorean theorem, I'm going to call that x. It's going to be x squared plus 8 squared equals the square root of 89 squared. So x squared plus 64 equals square root of 89 squared is just 89. And then we're going to subtract 64 from both sides. So 89 minus 64 is 25. And then we're just going to take the square root. So x is going to be 5. So AD is 5. Well, now that we can see, we have two sides, and we know that these angles are congruent. We're going to check side angle side. So we know that angle D is congruent to angle D because they're both right angles. And then checking my ratios, I'm going to match up my sides. So 5 is the smaller side, so that's going to go with 3. So 5 over 3 has to equal 8 over 5. Well, 5 over 3 is about 1.67, and 8 over 5 is 1.6. Since those are not equal, we would say that these are not similar. And the reason is that the sides are not proportional. So even though the included angle, which is the right angle, is congruent, we would need these sides to be proportional for them to be similar. All right. For problem number 3 and 4, we're basically doing the same thing. Okay, so number 3, we're going to see if these two triangles are similar. So again, this is kind of like number 1. 2 sides are given, the third side's not given, which makes me think it's going to be side angle side. But in order for it to be side angle side, I have to check that the included angle is congruent, which it is. So angle AEB is congruent to CED, and the reason is vertical angles. And then I need to check my ratio. So 8 is the small, 12 is the medium, and then on this side 3 is the small, 6 is the medium. So setting up my ratio, it's going to be 12 over 6. That has to equal 8 over 3. Well, 12 over 6 is 2, and 8 over 3 is 2.67, and those are not equal. So we would say not similar, and the reason is it's because the sides are not proportional. So since they're not similar, there's no similarity theorem, and there's no similarity statement. All right, number 4. So in looking at this, the given information is all 3 sides. So it makes me want to check side, side, side. But in order to check side, 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 we have to match up our corresponding sides. So I'm going to match up my small sides. I'm going to match up my medium sides. And I'm going to match up my large sides together. Alright, so first starting with my small, it's going to be 104 over 48, and that has to be equal to my medium side, so 117 over 54, and that has to be equal to my large sides, which is 156 over 72. So then we put it in our calculator. 104 over 48 is 2.17. 117 over 54 is the same thing, 2.17. And then we have 156 over 72, again, is about 2.17. So this means that the sides, well, actually I'm going to write the corresponding sides are proportional. So that means they're similar by side, side, side. And then my similarity statement, I'll start with a smaller triangle, so JKL is similar. So I started with JKL, so the green and red side, so that's going to be F. And then I went to the green and blue side, so that's going to be H. So it's going to be FHG would be my similarity statement. All right. Now let's move on to concept B. So concept B, we're finding the length of AC and CB. So AC is right here. I'll call that X. and then CB is right here. I'll call that Y. And we know the two triangles are similar. So since the triangles are similar, we can set up some ratios using the given side, which is 15. So 15 over 25 equals x over 12. So I'm just matching up my sides, 15 and 25, x and 12. And then we just cross multiply. So 25x equals 15 times 12, which is 180. And then divide by 25. We get 7.2. So that means AC is 7.2. And now we're going to solve for y. So y over 36 equals, again, I'm going to use 15 over 25. And like the previous one, we're going to cross multiply. So 25y equals 15 times 36, which is 540. And then divide both sides by 25. Get 21.6. So CB is 21.6. Alright, number 6, developers divided triangle lot shown, solve for x and y, show all work, and state the theorem used. So this theorem is proportional segments theorem. And remember, what's nice about these ones is you just have to set them up consistently. So for instance, you can do up, down, or you can go left, right, left, right. So I'm going to do 45 over 60. So I went up, down equals 24 over x. That's how I'm going to set it up to solve for x. So cross multiplying here. That's 45x equals 60 times 24, which is 1440. And then we're going to divide both sides by 45. So x equals 32. Now solving for y, I'm going to use the same first ratio, so I'm going to use the 45 over 60. And I'm going to set it up using this other proportionate here, so 33 over 3y minus 2. And now we cross multiply. So this one's a little tricky because remember, when we cross multiply here and we're multiplying to two things, we're basically distributing. So we're going to do 45 times 3. That's 135, so it's 135y. And then 45 times negative 2 is negative 90. And then we do 33 times 60, which is 1980. Now we can finish solving, so I'm going to add 90 to both sides. So 135y equals 2070. And then I can divide by 135. So about 15.33. Alright, next problem. We're solving for y. We're going to state the theorem. So this theorem for both of these problems is angle bisector theorem. But you can set up the same way as you set up the previous one. So as long as you're being consistent, that works. So I'm going to do y over 28. That equals, so I went left, right, so y over 28 equals 9 over 21. Then we cross multiply again, so 21y equals 9 times 28, which is 252. And then divide by 21. So y equals 12. Okay, b we're going to set up a similar way. So I'm going to set it up left, right, so 20 over 24 equals 2y over 2y plus 2. And then we cross multiply. So 24 times 2y is 48y. And then multiplying across this way, we distribute, so 20 times 2y is 40y, and then 20 times 2 is 40. So to get y by itself, we're going to subtract 40y. So this is 8y equals 40, and divide by 8. So y equals 5. All right, number 8 says we're given that ABC is a triangle. It tells us that M is the midpoint of BC, which means that these segments are equal. It tells us that N is the midpoint of AB, which tells us that these two segments are equal. And we're given that AC is 15 and NB is 3. We want to find the length of NA and NM. So because M is the midpoint and N is the midpoint, that makes MN the midsegment. So MN is the midsegment since it connects the midpoints of the other two sides. So we're going to use triangle midsegment theorem. So since MN is the midsegment, we know that the midsegment is half the length of the side that it's parallel to. So that means to get MN, we're just going to do 15 divided by 2, which is 7.5. So MN is 7.5. Okay, the other thing they asked for is NA. Well, NA is right here. Well, that's just going to be 3. And the reason for that is because N is the midpoint of AB. So that means that BN equals NA. And if BN is 5, that means NA is also, or sorry, if BN is 3, that means NA is also 3. Sorry, this should say NA. So in terms of explanation, this one you do have to explain a little bit more. You have to explain why you know that MN is the midsegment. And then you do need to explain how you know that NA is equal to 3, since there's no work to be shown there. All right. So now let's take a look at concept C. So these are the word problems. All right, so starting with number 9, it says a superhero slides down a 25-yard wire. So that wire stretches from there to there. And it says that the window's 2 yards below the top of another building. So that's that part right there. Her photo is taken by a photographer when she's at point A, which is 8 yards below the top of the taller building. We want to know how far she'll have to go to reach the window. So we're looking for that length right there. So this is 2 triangles. I'm going to draw them separately. So starting with my big triangle. Here's the big one. I know that this is 8, and here's where we need to be careful. The hypotenuse of this triangle is not 25. Remember that 25 represents from the beginning point all the way across to the other side. So this point from here to here is 25 minus x, because we're subtracting the part from point A to the other building. Okay, my other triangle, which I'm just going to flip it around here, we know that this is 2, and the hypotenuse of that triangle is x. So the tricky part of this question is getting this hypotenuse. But once we draw them separately and have those labeled, it's pretty easy to set up. It's just going to be 8 over 2 equals 25 minus x over x. And then we can cross multiply. So 8 times x is 8x. And then 2 times 25 is 50. And then 2 times negative x is negative 2x. Now we're going to add 2x to both sides. So 10x equals 50. And then divide by 10. So x equals 5. So to complete this problem, you do need to write your answer in a complete sentence. She will need to travel 5 more yards to reach the window. Remember, on this concept, to get full credit, you do need to write your answer as a sentence, since it's a word problem and it should have a word answer. All right, now looking at number 10, it says if your eye is 67 inches above the ground and you are 52 inches from the mirror is 95 inches from the palm tree. We want to know how tall is the palm tree, so that's where x is going to be. All right, so once it's labeled, it's fairly easy to set up. We're just going to do the vertical over the vertical, so x over 67 equals 95 over 52. Cross multiply, so 52x equals 67 times 95 is 6365, and then divide by 52. We get about 122.40. So the palm tree is about 122.40 inches tall. All right, number 11 says that Victoria holds a 5.6 long fishing pole. Oops. And the fishing line extends 3.2 feet to the water surface and then another 14.8 feet to a hook. How far is the fish from the hook? So the picture's already drawn for us. It's just a matter of setting it up. So this one we're going to set up the horizontal over the horizontal equals the vertical over the vertical. So it's going to be 5.6 over x equals 3.2 over 14.8. All right, then we cross multiply, so 3.2x equals 5.6 times 14.8, 82.88. And then divide both sides by 3.2. So x is 25.9. So the fish is 25.9 feet from the hook. Okay, so number 12 says a surveyor located at point S wants to determine the distance AB across the lake. The survey establishes points C and D so that CD is parallel to AB. First of all, we're going to prove that the two triangles are similar. So first of all, I'm not going to use any of the side measurements because we don't have enough information here, but I do know a lot about the angle. So first of all, I know that angle S is congruent to angle S because that's a shared angle. I also know that angle SCD is congruent to angle SAB, and the reason is since these lines are parallel, those are corresponding angles. And corresponding angles are congruent. So that means that they're similar. So similar by AA. And since they are similar, that allows us to use similarity, properties of similarity to solve for missing side. In fact, using proportions. So it's going to be 7.2 over x So this side over this side equals 10 over the big side of the triangle, which is 80. So cross multiply here. So 10 times x is 10x. And then 7.2 times 80 is 576. And now we can divide by 10. So x is 57.6. So the distance across the lake is 57.6 meters. All right, moving on to our last concept, which is dilations. So number 13, it says, draw and label the image produced when DEF is dilated by a scale factor of 2 centered at the point 5, 6. So first I'm going to draw the point 5, 6. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. This is point O. And then I'm going to extend my lines from point O. So extending from O, going through every point. Remember that this helps us ensure that we're doing the dilation correctly, because if we draw a point and it is not on that line, we know we did something wrong. We either counted wrong or multiplied wrong. All right. Now what we need to do is we need to determine how far away each point is from the center of dilation. So starting with point E, we go 1, 2, 3, 4 to the left, and then we go down 3. And then D, I go left 1, 2, 3, 4, 5. And then I go down 1, 2, 3, 4, 5, 6. And then F, I go left 1. And then I go down 1, 2, 3, 4, 5, 6, 7, 8. So if we're dilating by a scale factor of 2, that means I'm just going to multiply these distances by 2, and that's going to give me my new points. So E prime, I'm going to go left 8, down 6. D prime, I'm going to go left 10, down 12. And F prime, I'm going to go left 2, and I'm going to go down 16. All right, so starting with my center dilation, I'm going to go left 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go down 6. 1, 2, 3, 4, 5, 6. And I know I'm right because it falls on the correct line. And then now D, I'm going to go left 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's D prime. And then F prime, I'm going to go left 2 and down 16. So 1, 2, and then I'm going to go down 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's F prime. So now I have my points. Now I just need to connect them. And then we're done. All right, now let's look at the next one. So number 14, we have to graph this one first. So P is negative 6, 4. So there's P. Q is negative 2, negative 2. Oops. And then R is 4, 0. And I'm just going to connect these points. And then we're dilating by a scale factor of 1/2 centered at the origin. Well, remember when we're centered at the origin, we can just multiply the points. So if P is -6, 4, I'm just going to multiply that by 1/2. And that's going to give me P prime. So -3, 2. Q is -2, -2. But I'm going to multiply that by 1/2. So Q prime is going to be -1, -1. And then R is 4, 0. So I'm going to multiply that by the scale factor. So that means R prime is going to be 2, 0. Remember that you can only do this if your center of dilation is the origin. If the center of dilation is not the origin, you are not able to do this. So plotting my new points, there's P prime. Q prime is -1, -1. And then R prime is 2, 0. So there's my new figure. And you could do this the normal way where you draw your lines. You would end up with the same thing. All right, number 15. Our center of dilation is -2, -5, which is right here. Point O, I'm going to go ahead and extend my lines through each point since I have to do this the long way. Okay, now I'm going to write out my directions. So starting with S, to get to S, we go left 1, 2, and then we go up 1, 2, 3, 4, 5, 6, 7, 8. And then T, I go right 1, 2, 3, 4, 5, 6, 7, 8. So right 8. And I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then U, I go right 1, 2, 3, 4, 5, 6. And then I go up 1, 2, 3. So using a scale factor of 1/2, I'm going to multiply each of these by 1/2. And that's going to give me my new points. So S prime, I'm going to go left 1, up 2.5. T prime, I'm going to go right 4, up 5.5. And then U prime, I'm going to go right 3, up 1.5. So multiplying by 1/2. And that's going to get me my new points. So S left 1, up 2.5. Oh, I just realized I think I counted S wrong. So counting S, I go left 2, up 1, 2, 3, 4, 5, 6, 7, 8. Not really sure why I wrote 5. So I'm not going to go up 2.5. I'm going to go up 4. Okay, so here's how I knew I did that wrong. When I was plotting my points, I didn't hit the line, which told me I did something wrong, and it was far off enough that I knew that it wasn't my line that was off, it was my counting that was off. All right, so S prime, go left 1, up 4, 1, 2, 3, 4. So now I'm on the line. T prime, I'm going to go right 4. So 1, 2, 3, 4. I'm going to go up 5.5. So 1, 2, 3, 4, 5.5. And then U, I'm going to go right 3. 1, 2, 3, up 1.5. So there's my new figure. All right, number 16, we're dilating at the origin. So again, what I'm going to do is I'm actually just going to write out my point. So I is -1, -1. U is -3, -2. And X is 0, -3. And since I'm dilating from the origin with a scale factor of 2, that means I could just multiply these coordinates by 2. It's going to get me my new points. So I prime is going to be -2, -2. U prime is going to be -6, -4, and x prime is going to be 0, -6. So plotting my new points in blue, so -2, -2, there's I prime. U is -6, so 1, 2, 3, 4, 5, 6, and -4. And then x prime is 0, -6. There's my new figure. All right, number 17, it says, given the dilated figure, determine the scale factor, explain in detail your reasoning using academic vocabulary. All right, so looking at these, the first thing we should do is determine where the center of dilation is. So what I can do to do this is I could just connect my corresponding points, and wherever those points meet up is where my center of dilation is. So connecting A and A prime, it meets at the origin. So the center of dilation should be the origin, but I'm just going to confirm by connecting the other corresponding points. And when I connect them, they all meet up at the origin, which means I can use my rule of seeing what we multiplied by to get my new points to figure out what the scale factor is. So the coordinates of A is 2, 1. A prime is 6, 3. B is 5, 1. B prime is 15, 3. And then C is 3, 6. And then C prime is 9, 18. So in looking at these, we know that our figure got bigger, which means our scale factor is going to be greater than 1. And to get from A to A prime, we multiply by 3. And that's the case for each one. So that means our scale factor is going to be 3. So in terms of reasoning, I'm going to say the center of dilation is the origin. So you can see the pattern to get the new points, or get the prime points, is multiply by 3. Okay, I'm also going to say that you know the scale factor is greater than 1. Because it's an enlargement. All right, so let's look at the last one, number 18. So we're doing the same thing. So first I'm going to determine where my center of dilation is, and the way I'm going to do that is by connecting my points and see where they all meet up. So this one looks like it's going to be the origin again, but just to be sure, I'm just going to connect all my corresponding points and see where they all meet up. So they all meet up at the origin again. And it looks like my figure is getting smaller, which means my scale factor is going to be less than 1 since my prime points are on the smaller figure. So what I'm going to do, just like the previous one, since my center of dilation is the origin, I'm going to list out my coordinates, and I'm going to see what the pattern is. So P is -2, 5. Q is 1, 2, 3, 4, 2. R is 4, -4. And S is -4, -4. And now what I'm going to see what my new points are. So P prime is -1, 2.5. Q prime is 2, 1. R prime is 2, negative 2. And S prime is negative 2, negative 2. So looking at this, what seems to be happening is we're multiplying by 1/2 or dividing by 2. So that means my scale factor is 1/2. So the reason I know this is kind of the same reasoning as before. Since the center of dilation is the origin, you can see the pattern. Is multiplying by 1/2. Which means the scale factor is 1/2. You know that the scale factor is less than 1 because it is a reduction.